will exist on the internet forever. Ugh.
All right, so 5 to the x. The best way to do this is to get e somehow. Can I get e as I can? Because this is going to look extremely cheesy. Remember how e to the natural log of x turned out to be just x because these two are inverse functions, they undo each other. I can use that idea to get 5 as a power on e. It's e to the natural log of 5. It's 5. E to the natural log of 5 is 5. Now what happens when you have a power to a power? Tell me what to do. Something to a power to a power. What do you do with the powers? Multiply. This is e to the x natural log of 5. Now don't let the natural log of 5 screw you. Sorry. I'm so excited. Natural log of 5 is a number. This is the number. It's not a long name. This is the number. It's like me. I know. I'm talking to my grandma, professor of mathematics. Do quite honestly. Yeah, right. We need this at no time. So back to work here. I am now ready to take this derivative. This is like taking the derivative of e to the 2x. Oh, it's a chain rule problem. Because I don't have e to the x. I have e to the something more than x. Chain rule says do the following. It's derivative of the outside, inside unchanged, times the derivative of the inside. Oh my gosh, and what is e to the natural log of 5x? Isn't this just 5 to the x? It is. This piece here is this piece, which is this piece. So when you do the derivative of 5 to the x, all you have to do is write 5 to the x natural log of 5. It's got an extra factor of the natural log of the base. That's it. That's a nice little shortcut rule. You can handle any base. X power. All right, let's just to make sure you got it. What would be the derivative with respect to x of 5 to the x squared? Hit me. Can anybody do the pro move? I can. Pro move. Ready for the pro move? That's the pro move. You throw the derivative of the inside down first. 2x, natural log of 5, 5 to the x squared. A lot of people put this natural log of 5 after, because then you don't have the 5's next to each other in the print face. But that's the pro move. That's it. The derivative of the power is going to be a 2x. It's going to happen. So stick it out front. That's the pro move. All right, so try this one. What say you? It's not log to the base e, it's log to the base 10. Can I rewrite it? Well, let's try it this way. There's two ways to do this problem. One is to rewrite in terms of log to the base e. Another one is to say, okay, this whole thing is like derivative with respect to x of g of x. Okay, so this is g of x. I can rewrite this as 10 to the g of x is equal to x. And now I can try and find g prime of x by taking the derivative. Do that one. Let's take the derivative. What's the derivative of 10 to the g of x? It's going to be 10 to the g of x times derivative of g of x times the base wasn't e. The base was 10 times natural log of 10. So, and that's equal to, what's the derivative of x? You're so smart. 1. So, g prime of x. g prime of x is equal to 1 over natural log of 10, 1 over 10 to the g of x. What's 10 to the g of x again? 10 to the g of x is x. We just did this. 10 to the g of x is x. It's right there. We just did a notational thing. So the derivative of the base not being 10 is just like the derivative of natural log. You get 1 over x, but it's 1 over the natural log of the base instead of just times the natural log of the base. That should make sense to you. Because remember, they're inverse functions. The natural log of x are inverse functions. The derivative of 5 to the x has a factor of natural log of 5. The derivative of log to the base 10 x has a factor of 1 over natural log of 10. It makes sense that it's not just a natural log of 10. It's 1 over natural log of 10. Logs in the end are inverses of each other. Derivatives of inverses play a reciprocal relationship. That's one of the things that don't memorize. It's a reciprocal relationship. So the author of the book did a good thing. He put all these ideas right next to each other. First section, inverse functions. A nice little trick that you'll never be used, but it reminds you that when you do functions and inverses and derivatives, there is a reciprocal relationship, and it helps you remember the shortcuts. So put it all together. There's my summary, which will live forever. I'm shutting it down.